Today we're going to look at the Mustool MT13SPRO Digital Multimeter with IR thermal camera that I got from banggood.com. They sent me this one to evaluate. We're going to check it out, see what it does, check it for accuracy, going to take it apart, and just kind of play around with it. This is a cool tool. This is going to be one that'll be a welcome addition to my test bench. Two tools in one. We'll see how long it lasts, but construction-wise, it looks to be pretty good. Kind of let the cat out of the bag with the last video because I showed this before I was ready for showing you. But this is the Mustool MT13SPRO. It's a meter. You saw it already. We do the official unboxing. Got this from banggood.com, and they sent me this to take a look at and try out and show you guys what it can do and what it can't do, and well, what it can do. It's a little meter. It has a built-in rechargeable battery with a USB-C port, so you can charge it up. Comes with your standard stuff, standard probes. It also comes with this little thing, this little gadget here, which is well, it's it's a lens of some type. Why would a meter have a lens in it? That doesn't make a lot of sense, does it? Why would you need a lens with your multimeter? Well, this is not just a multimeter. This is also a thermal imaging camera. That's right. Some of you may have seen this on the last video. It's a thermal imaging camera with non-contact voltage detection and capacitance meter. It'll measure temperature, measure the frequency, and oh, it has all kinds of cool features on it. But there is the camera in the back. It features a rechargeable battery, which you can actually change. If I unlock it, here is the battery here. It's just a standard little 1000 milliamp hour 3.7 volt battery, and I'm sure it plugs in somewhere in there, but yeah, probably have to take it apart to get at the wires. Anyway, that's beside the point. It has a battery that can be removed. To avoid electric shock, please pull out the test pin before removing the shell and battery cover. They don't want you opening it up when it's energized, obviously. So I take it this is probably fits on here kind of like this, and it's probably for close-up work. I would think that's for close-up, for looking at stuff that's close-up. I don't know why it's yellow, but it is. It's a yellow lens. And you can't really, well, you can't really see much through it. I guess if you're really, really close. Oh yeah. Yeah, if I look at it up to my eye and I bring my fingers right up close, I can see it. It's a close-up lens. That's what that is. Alright, let's turn this thing on and see what it does. First things first, let's plug in the probes. And we'll do some measurements, check it for accuracy. We'll compare it to my fluke. Put the probes in like that. To turn this meter on and off, there's a power button. You've got press and hold. That turns it on. Okay. Get the nice liquid crystal display. It has a touchscreen. We press the touchscreen. It's in auto range. So auto range will measure anything. If I put the probes together, it's telling me that depending on how tightly I hold the probes together, 0.0 ohms. If I pick up a battery, don't know what kind of a charge is on this battery, but if I pick up a battery, kill this light, maybe make it easier to read, and I measure the battery, it's 1.574, and it's fast, right? Touch it, got a reading right away. That's pretty quick. What if I take it and I plug it into my 120 volt outlet from my transformer? Now again, it's in auto, and I will plug it in, and it tells me that's 121.2 volts at 59 hertz. Should be 60 hertz, but it's saying it's 59, but maybe it is 59 hertz or pretty darn close to 60. Anyway, that's measuring that. Settings over here. your system settings. Got multimeter or boot up with either IR camera or multimeter. Automatic shutdown time off, 5 minutes, 10 minutes, 20 minutes. Official language, Chinese, English, or German. Setup time, oh, that's for setting up the time and date, okay. And back. About, gives you the firmware version. And USB mod, it looks like it can be updated. Yeah, you can update it over USB. IR camera. Okay, here's how you set the camera. So you can have it either color or a black and white. So white hot or red hot or color. So you can set your different modes for the camera. And you can also check the emissivity. You can set that up. And your temperature levels, auto, high, or low. And it has settings, preset settings here for emissivity for different materials. Back. Multimeter. Auto, non-contact voltage detection. Temperature, DC voltage, ohms, continuity, AC voltage, diode, and capacitor measurement. And the button mod, hold or range. So this button over here, you can hold or select your range. So it's right now it's set for hold. So in other words, if I measure something and I tap that button while I'm measuring it, it will hold the display. If I tap that, I've now held the display. I guess I tapped it after I pushed the button. My probe slipped there too, which was kind of interesting. I just got myself a bit of a burn. Okay, so if I measure the battery and I hit the hold button, it will hold that display like that. What happened is my probe, when I was measuring, my probe slipped off the negative terminal and the positive terminal is right there. So I actually dead shorted and I thought, why is this thing getting hot in my hand? Because my probe slipped and shorted the battery out. On alkaline batteries, the actual case is the positive electrode and the negative is this one here. And there's just a small little gap between them with a bit of an insulator, but unfortunately on these cheap Kirkland batteries, the negative terminal is right there. So if you were to short something between that edge and here, well, I mean, if we turn off this, you'll see what I mean. If I put my meter on here, I can actually measure the voltage on one end of the battery. Put my meter there, and you see? So it's easy to short these things out. Gotta be careful with these cheap Kirkland Signature Costco special batteries. Let's try some other types of measurements. Let's try measuring a couple of resistors here. What do we have here? We have a 1K resistor, brown, black, red. Oh, let's make sure that the display doesn't go out. And I just tap there, and you can see nice and quickly 998.5 ohms. Let's grab another resistor here. What is this one? This one is a brown, or green, blue, orange. Oh, I'm not making a connection. That's a piece of wire there. Do it here. 55.8K. So both be 56K. It's pretty close. Next, what do we got here? This one here is red, black, yellow. So it should be about 200K. It's measuring 195.6K, which is well within the spec for a resistor of this type, because it's a, I think it's a, is it gold band, or I think it's gold band, so it's 5%. Whoops, I threw that into the wrong bin. But resistor measurement, it is measuring resistors just fine. Get our light back up here. Where are we here? Right. 20K, 1 9 and 3 zeros, so 19K. Measuring 20K. How does the resistor measure up to the fluke? How does that resistor measure up? Let's see here. We'll measure it to the puke meter. Puke meter says that this meter is 20K, 20.1, and the Mustool says it's 20.1. So we're right there. How about this one? Okay, try that again. 70K, 70.3K. And we'll do the same on this meter. $73.5. 73. 73K. $71K. It's supposed to be 68. So, again, old resistor, 10% tolerance, silver band. So, that looks okay. Let's go to the next thing we're going to measure, and that's capacitors. And I've got some small and big caps here. So let's put this into capacitance mode. This one here is measuring. Oh, maybe I have to select. Do I have to select capacitance? I might have to select capacitor separate on this. Let's try capacitor. Okay. So 119 nanofarads. This one says 0.12 microfarads. Quite often when you're measuring these really small capacitors, you will get discrepancies as well. And these ones are pretty old. Just a box of like old caps that was given to me. What do we got here? This one here is a 100 picofarads. Looks like 0.1 nanofarads, that's 100 picofarads, right? Move the decimal 3 points, so up, and you're at 100. So this one here is measuring 107 picofarads, and this one here is going to measure it. Should. I don't want to touch it because I don't want my skin resistance to affect it. The fluke might not measure that low because it's in microfarad mode. So interesting. The fluke's not going to measure this cap. It says it's 0.00, but this one certainly is measuring 100 picofarads. 0.93, right? 100 picofarads would be 0.1 in measuring in nanofarads. Let's measure some bigger caps. Just see what some larger caps in the microfarad range measure. So I've got a 330 microfarad cap here. We'll look at it on the puke meter first. Puke meter says it's 331 microfarads, which is looking good. Let's measure on this one and see what this one says. Will it even measure that big? It's measuring. There we go. 329.4. And it switches from nanofarads to microfarads, you see? So this can measure much greater range of capacitors than the other one. Let's try a 1000. I think this is 1000. Yeah, 1000 microfarad cap. Let it measure here. It's going to take it a few seconds, I'm sure, to charge up. as it's measuring it. And there it goes. So it's got a little M on there. So it's not microfarads anymore. Is that millifarads? Anyway, it's got a 1.012 millifarads, which is 1,000 microfarads. Just a little way that the display shows a little different. And if we measure it on the puke meter is going to say 1,000. It's accurate. Okay, I think that's fair enough for that. I just want to try something else here. I'm going to go back to auto ranging, and we're going to shove this thing into AC power once again, because I want to see what this hertz percentage thing does here. Press that. What does that tell me? It says 60 hertz. Okay, yeah, we know that, 60.3. But press that one again, and oh, the percentage. Here we go. That's obviously our duty cycle, which is going to be 50% for our sine wave. If it was a PWM, it would give you your percentage, your duty cycle for on versus off on a PWM waveform. Let's check it for DC voltage next. So checking for DC voltage, turn on the puke meter, and we are in DC voltage mode. And I'll connect the probes up here to my meter, and we see we get 3.281 volts. I'll connect this meter at the same time because we're going to run the power supply up and down here a bit. If I can get them both on here at the same time. But 3.277. Please connect up a couple jumpers and we'll run these both at the same time. And then I can run the voltage up and down. And as I ramp up the voltage, 4.86, 8.7, 11.8, 14.5, both tracking exactly, 17.13 and 17.12. We're splitting hairs here, 19.51. 23.4, 28.2, and the maximum that my power supply can go, 32.17, 32.16. Close enough, close enough. It's accurate. It will be a fluke or a Mustool if it's accurate, I guess. That's a pass. We'll check some transistors. Some old transistors. A diode test mode. NPN, so base here. Okay, emitter to base. 0.659 drop. Collector to base should be I think this transistor is no good. This transistor has failed. There's no junction between the base and the collector. This transistor is foobar. Got one junction good, one junction bad. Let's try another one. What do we got here? These are all just were given to me, so don't know what shape they are. This is a CBE, it looks like. So NPN, positive on the base. There we go, 0.6 and 0.6, and open between emitter and collector. This transistor's good. Let's go to the other meter over here. Can I do it in auto, or do I have to switch it? Let's find out. Positive on the base. It measures in resistance as opposed to diode test, so I got to hit diode test on here, and then when I go on diode test, it says we have a 0.6 volt drop, and we have on this one here, we also have a 0.6 volt drop, and between emitter and collector we should be open, which we are. So that transistor is good. So the diode test function works good. And if I go back to that one that's going into the bin, because it's no bloody good, if I connect my positive to the base and put my negative onto the collector, which we know is open because the fluke says it was open, and it is indeed open, and over to the emitter, and this one measures good. So this has become a diode instead of a transistor. Maybe we'll cut this thing open at some point and show you guys what's inside this old transistor. I'll just put that aside. Okay, so diode test works, but what we haven't shown you guys yet is probably the most important feature of this meter, and that is the thermal camera. And it will actually do both at the same time. If I press the thermal camera button, the thermal camera will turn on. It takes 5 seconds to calibrate. And there is the thermal camera. And you can see things that are warm in here, such as my transformer. So, there's my transformer. Oh, there's my hand, right? So you can see it's a lot hotter, and it will actually measure the temperature. I've got it set up in Fahrenheit right now. It'll do Fahrenheit or Celsius, but it's 84 degrees Fahrenheit right here, according to this. But this is what they call the iron rainbow, I guess. My plasma screen is really hot. It's running, and you can see the temperature of that. It's hot. If I turn on the soldering iron, what will happen if I click on the soldering iron? We'll be able to watch this thing getting warm. So there it is, it's on, and we'll start to see that tip get real hot real quick. Where is it? There it is. You can start to see that tip right here getting hot. The reason it just froze is it's switching from low temperature to high temperature mode. Go into protection mode because this is going to get way too hot for this thing. I got to put it into the high temperature mode. Might even switch it automatically, but yeah, look at that. Can you see the hot spots on the iron? If I zoom in a bit onto this, and this can record too. You can record this. You can take pictures and you can actually record. It has memory built in, and you can download it as well. But this is 700 degrees now. I timed out. I can change that settings here. Backlight and sound, I think that's the one. And backlight settings 80%. I'll turn my screen time to 2 minutes. There, it's switching from low to high temperature mode again. That's why it freezes as it switches modes. You can see the hot spots on the iron there. That's kind of cool. It should switch back down to the lower temperature range now. It switches between high and low. So when I pointed it at the soldering iron that was so hot, it froze for a second because it had to change the calibration to the high temperature setting. Now it's back on the low setting. See, it's measuring my skin temperature at 97.5 Fahrenheit. It also can operate as a meter while you're in voltage measurement or in infrared camera mode. So, for example, if I've got the meter set up here and I'm just looking at something and I'm measuring voltages at the same time, which is kind of tricky because you're going to be holding the meter in one hand and you'll need a third hand for this. I guess if something was grounded, you could do it. If you had a probe grounded and you're holding the meter in one hand looking at something and you got a probe that's connected to ground, then you could in theory turn something on and watch the voltage and watch for something getting hot. So for example, if I can set this up, can I do this? Can I do this? And you guys see what I'm doing. Oh, there's a bee flying around here. I can hear it. I can hear the bugger. Okay, this is really tough to try to hold this, but if I do this, it will tell me that the battery is 1.55 volts. So yes, I can measure voltage at the same time as I'm looking at the infrared camera on one device. How cool is that? That's pretty cool, if you ask me. That's pretty cool. So you can use the thermal camera for looking for a fault while you're monitoring the voltage on the same tool. Monitoring something you're turning on, for example, to see if there's a voltage drop and anything's getting hot. You'll see the temperature increasing on the display while watching your voltage. That's kind of cool. If I put the close-up lens, there's a bee in here. He's going to meet Mr. Electric Fly Swatter in a minute if he's not careful. Put on the close-up lens and then it'll bring things in close-up into focus. And then remove that for the normal viewing. Press and hold the power button to turn off. Let's take this thing apart and see what's in it. Oh, it's got a screw on here that if I break this seal, I'm going to avoid my warranty. What warranty? I don't have a stinking warranty. I want to see what's in this sucker. So let's just remove some screws and take it apart. Might not ever work again, but and this is not a cheap tool, by the way. This is a couple $100 this thing. It's not a cheap, it's not a toy. This is not cheap. This is an expensive little gadget. This is in the range of fluke meters. But we want to see what's in it. So this should, oh, the bezel comes off, okay. But, uh-oh, now I've done it. Now I've done it. Buttons just fell out. These don't do anything. Oh, I see what that's for. That's just a cover. This is a universal. Looks like maybe some other models may have had a function switch here. So they've just covered that up. There's no switches on here, just these ones. Let's see if this circuit board will lift out. Maybe it will. Maybe it won't. It probably won't. It's probably secured down somehow. This is the LCD screen. I don't want to break it. Because again, I just got this thing and this is, you know, a relatively expensive little meter. But I wanted to see what was inside it, and we've seen it now, and there's really not a hell of a lot to see because it doesn't appear to want to come apart any more than this. I see another screw. Maybe this screw will lift out the circuit board. Let's try that. Ah! There we go. Now we can see it. So there's the circuitry. It's got a lens on the front here that blocks visible light. So I guess if this were to be turned on with that infrared filter off, it probably would even see visible light. Let's turn it on and see what it does when I press the power button down. Will it turn on? We'll switch it over and see what happens. Will this thing see visible spectrum now that the filter is off? It probably will see everything. It still sees infrared, but it sees more of what's around, that's for sure. This filter that's on the back here is obviously there to stop visible light from passing through, and you can't see anything through it. It looks completely black. But if I try shining a bright light through it, will I see anything? Probably not. It's probably going to block all visible light. This might be damaging to the... yeah, you see, look at that. That little square completely blocks the visible light. You see nothing. You see light shining through the plastic, but you don't see anything shining through that little square. It blocks everything. So that's an infrared pass filter is what that is. I'm going to throw this thing back together momentarily because I'm sure it's not good to have it pointing at light. There's the plug there for the battery, so you can take it apart and replace the battery on it. That's simple enough. And look at the chipset in here. This is interesting because the chipset doesn't have any numbering on it. These chips, they've etched the tops of these chips. Take a look at this. I'll get a close-up. Look at the numbering. They've etched the top of the chip, so you can't see what these chips are. How's that for protecting your intellectual property? To stop someone from copying your design. Just etch the chips down. That looks like they cut them down with a laser or something, but you can actually see there's a ridge on here where they've actually milled off a portion of the epoxy. So it's probably a universal standard, readily available chip that they're using on here, but they don't want anybody to know what it is. And the old way of just sanding off the numbers didn't really work because people would etch them with acid a bit and they could always pull the numbers up. At least that was always the way that I was shown it was done, where people that would sand down the numbers, you could just put a bit of acid on there and you could actually see the impression. And they've taken it to the extreme. They've actually milled it down, and you can feel it. They've milled down the surface of the chip completely, so you have no idea what chip that is. That is called protecting your design. I love it. They don't want people copying them and making knockoffs. That is wild. Construction-wise on this thing, it looks to be really good. There's you can see the branding on this, or the model or part number, FR01D. This feels like it's 3D printed, this little housing. It probably is. And then there's the camera sensor there that just plugs in. But that is, yeah, I'm impressed. I'm impressed with this little meter. Wow. Now, I have to be sure that I get this thing back together right. So I got to put these pieces back on. And how did this go? This went on like this. I guess this went on like that. Gee, I forget. These slid into the front here. So these went on. That went on like that. And the negative one went on like this. And then this slid down like that. And then that screw holds down the board. Just like that. And then I had the contacts. These went on like this. Throw this thing back together. Hopefully it will go back together and still work. That'll work. It'll work. No problem. There it goes back together. Just like that. And then the 4 screws into the back and the battery into the bottom here. And my little $200 and some odd meter is back together. And no worse for wear. Anyway, I think I've probably shown you all I can show you on this unit. I'm going to put a link in the description. So far, I like what I've seen, and you'll be seeing this meter, I'm sure, on my channel. And we'll see how it works and give it a good run for its money. Okay, there it is. We'll take a look at the specs together here on this meter. So power on, press and hold the power button, duh. The switch, DMM, and IR camera function, you can have it start up in IR camera or DMM. I programmed it to turn on into DMM mode just because that's where you're going to use it most often. But you can set it so that it starts up in the IR mode instead, which will still give you your meter functions, but it'll give you the thermal camera. That's when it comes out of the box, that's how it is. It defaults to the IR camera. But I've just gone into the menu and switched it so that it starts up into DMM mode. And thermal imaging screenshot. So the IR camera interface, touch the screenshot button in the lower right corner and wait for the progress bar in the middle of the LCD to complete your screenshot. And you can view or delete the screenshot in setting storage. Vanadium oxide sensor. Image capture is 20 Hertz. It's 192 by 192 and the display is 240 by 240. Has a field of view of 50 degrees horizontal and 50 degrees vertical. Temperature range is 0.1 to 0.99 adjustable. Temperature range, that's for what it's measuring. Temperature range -20 to 550 Celsius. Auto gain. And it says iron red, rainbow, fusion, white heat, and white heat highlights. Accuracy is 2%. Measurement resolution is 0.1. Has a maximum input voltage of 1000 volts DC or 750 volts AC. 99.99 mega ohms. And the maximum capacitance is 99.99 MF. Not microfarads, but millifarads. I guess it's millifarads. Diode test range is 0 to 3 volts, and the continuity test is 999.9 ohms. Your display count is 4 digits up to 9999 counts, and it updates 3 updates per second. For the last test, we'll measure the AC tracking. I'm going to turn the voltage down with the variac and turn it up. Hopefully I won't blow anything up. Just unplug things that might be affected by excessive power. I could get everything unplugged here. Okay, let's turn the power down. Yeah, crank her right down. 10 volts. 50.5, 50.7. 104, 137, 151. It's tracking the voltage pretty good. Okay, so AC voltage, it tracks as well. Everything's pretty much right on there. I don't know how accurate my fluke is. It's old. I imagine it's fairly accurate, and I'm sure this one's fairly accurate too. Everything's looking good on here. The voltage wise, it's looking exactly the same. Non-contact voltage detection. We can tap here, and the non-contact range is up top here. So if I bring something that's emitting, this probably won't because it's on an isolation transformer, so I doubt this one will. But if I bring this near something that is not on an isolation transformer, we should detect. For example, I can bring the meter with or without probes. I can take the probes out for this. If I'm just looking to see if there's any voltage, right, I can detect induction near a wire that's live. So that will tell you if you've got an outlet that's live or not. Forgot to mention, if you tap here, that'll take a picture, so you can save your images. So if you've got something you're looking at, something that's hot, you just tap the screen right there. That's the save button. We can also change the view. If I go to settings and I go to IR camera, if we want to look at just a black and white image, we can select that one, and now we will see a white hot as opposed to a color image. Now you see white is hot and black is cold. A lot of times when you're looking at stuff on infrared, that's what you want to see. You want to look at the actual temperature in black and white. Makes it easier to see what you're doing. So right here you can see the transformer. It's glowing away. Many times it's a little easier to tell something that's hot if it's white as opposed to other surrounding colder areas. But you've got the option. That's one. The other ones are, you can have this one, which is white hot, or red hot, I think it is. It's black and white, but the hottest areas are shown in red, you see. So this one here, it's a black and white image, but the hot spots are shown in red. So that'll draw your attention to something that's hotter than anything else on the screen. The other settings are more false colors. And the last one is that one. So you get many different settings you can use to determine what is hotter and what is colder. See, now my hand looks red. Red is the hottest color on this setting. If I go back to the original setting. My hand is now more yellow. So now it's yellow hot. Now I've got an edge around my hand. See? Around the edges here. Sharpens things up. So there's 5 different settings. You can pick which one you like best. All in all, I think this is a very useful tool. I think a lot of people will benefit from having a combination DMM with a thermal camera built in. I think this is probably one of the better little tools that I've actually evaluated in the past, couple years. You don't need a thermal camera all the time, but when you do need one, why not have one in your meter that you're carrying with you? And as we can see, the measurements are every bit as accurate as my fluke. Will this stand up to the same amount of abuse as a fluke? Probably not, but again, if you look after your tools, that shouldn't be a problem. Obviously, you're not going to want to drop something on the touchscreen, because the touchscreen, you're going to break it. It's glass. If you drop something on here, you could very well break it, whereas the fluke, I don't worry too much about that. It's got a protective plastic lens in front of it. But again, a new fluke meter costs more than one of these. And for the bells and whistles you get on here, I don't think you can beat it. A couple $100, sure, it's expensive, but it is a lot of meter for what you're getting. So this one's the Mustool MT13S. Again, I got this one from Banggood. Looks to be a winner in my books, and you're going to see it more and more on my channel. I'll put a link in the description, and we'll catch you in the next one. Bye for now.